Now in this video, we're going to look at how to solve equations of higher degree, higher power. So if you look at the exponent of c, the highest power is 2. And also we have a c that cannot really combine with the c squared. So we are going to use factoring to solve these problems. So the idea is based on the fact that if we have product of two numbers, something times something equals 0, then one of them must be equal to 0. So first we want to make sure our equation, we can turn our equation into the format. So that means one side has to be 0, which we already have. The other side must have multiplication, which we don't have because we have, right now we have a minus. So I can use factoring to turn this subtraction to multiplication. So what we can do is to use factoring. So again, recall the 4 types of factoring: GCF, and difference of two squares, and trinomial, and grouping. So first we always check GCF. So we notice 5 and 20, they have a 5 in common. C squared and C, they have C in common. So we're going to factor out a 5C. And after we factor out 5C, we divide each of them by 5C. So 5 cancels 5. C squared divided by C is C. And minus 20 divided by 5 is 4, and the C cancels C. So we have the left-hand side factored. And you can see we have the multiplication we need between 5C and C minus 4. If you want to put a parenthesis for 5C, you can. And now we can say, since we have multiplication, if we multiply two numbers, we get 0, then one of them must be 0. So we can set whatever in each parenthesis equal to 0. So we have 5C equals 0 and C minus 4. So 5C equals 0 and C minus 4 equals 0. Now the only thing left to do is to get each C by itself. And in the first equation, since the operation between 5 and C is multiplication, we're going to divide both sides by 5. And so we get C equals 0, because 0 divided by 5 is 0. In the second equation, we want to get rid of that negative 4, so I add 4. So I got two answers, 0 and 4. So if you have time, you can plug these numbers back in the equation and check, make sure they satisfy the equation. Now in the second problem, C squared minus 25. First of all, I notice they don't have anything in common, no GCF. One of them have two C's, the other has 25, just a number. So we count the terms. We have two terms, C squared and 25. So maybe it's a difference of two squares type. And all we need to check is make sure we do have difference. D means difference, subtraction. And we need two squares. So we have a square here. All we need to do is to check whether 25 can be written as a perfect square, which we can. That is 5 squared. So now I can apply the formula to turn C squared minus 5 squared into a multiplication. So since we have two copies of C, we put one copy here and one copy there. Since we also have two copies of 5, because of 5 squared, we're going to put one copy here and one copy there. In order to generate minus from multiplication, we need to have plus times minus. Between the parentheses, we have multiplication here. So once we have the left-hand side factored, the right-hand side stays as 0. Now we can say set each factoring equal to 0. So we have C plus 5 equals 0 and the C minus 5 equals 0. In each equation, we get a C by itself. So in the first case, we're going to have to reverse addition. In the second case, we reverse subtraction. We do addition. So now we have 0 minus negative 5, that's negative 5, and 0 plus 5, that is 5. Again, we got two answers.